As I've mentioned before, functions are just named closures, and you can pass in a function anywhere you can pass in a closure. It's all about the type. Just like what we saw with sort, the type was a function that takes two strings and returns a Boolean or two ints and returns a Boolean. Well, that's what the less than operator does. So you can pass that in. So if you write a function that satisfies the type that needs to be passed in, you can pass in that function. So you want to try that out? I know you do. Let's do it. So back in Xcode, we'll take one of these examples. We'll do first long name, and I'm going to run that, and I'm going to remove this print on line 3 so that it just prints out optional Jenna. And I'm going to put in this no coalescing operator because I don't like the warnings and I don't like the optional. So I'll say no val there, and when I run it, it's going to say just Jenna. Okay, so we want to write a function that has the same signature, takes a string, returns a Boolean. So we'll say func, and the name of the function is longer than 4. It takes a string, we'll call the parameter val, string, returns a Boolean, open curly braces, and then the body is just going to be the same thing, return val count greater than 4. Okay, so now let's rewrite this call to names first. On line 7 through 9, I'll delete those, start over with the code complete. So first, and it takes that, so I'm going to pass in longer than 4. So that's the same type, takes a string, returns a Boolean, so the output should be exactly the same, Jenna. And there it is. Yes, so anything that satisfies that same type, in this case, string returns bool, can be passed in as that function. Hopefully you're saying, oh, yeah, I knew that. We already talked about that. Well, you probably are. You're getting very strong in this, and I think you're doing great. So let's move on. Now we're going to talk about something really cool. I really like closure optimizations. They really make the code focused and concise and really communicates, in my opinion, the intent of the code and also makes it hard for other people to change it in such a way that goes against the intention. So one optimization is trailing closures. We've seen this the whole time. I just wasn't pointing it out, but now we're going to look at it in detail. Also, inferred parameter and return types, implicit return of single expression closures. Then we're going to look at shorthand argument names. It all results in efficient, readable, focused, and clear on intent code. So let's look at some of these closure optimizations. So back in Xcode, we're going to look at some of our early examples. So I'm going to delete all the code except for our lovely names array. And the first thing we're going to do is we're going to call sort. So names.sort. And I'm going to use the one that doesn't have a return type. Now you see that the parameter is in the open paren, close paren, and it has the parameter name, or at least the argument label. But watch what happens as soon as I press return. Where'd it go? It's gone. This is called a trailing closure. If your last or only parameter is a closure, you can put it outside the parentheses. So it's kind of like this. Since there are no other parameters, we don't even need the parentheses. So it's just sort and then this trailing closure. You may say this looks weird, this looks different, I don't like it, and I get it. The first time I saw it, I didn't see the point. Over time, it actually makes more sense because this to me is a little bit more difficult to read. You have the by, colon, and then you got to remember to have this close parenthesis way down here. In some cases, if your closure is really long, boy, this can get far away. So to have it nice and clean, you just have the trailing closure. So of course I have my val1, v2, return v1 less than v2, and print my names. Now when I run this, I'm just doing a regular, just like we've seen before, and it's just a trailing closure. The next thing we're going to look at is inferred parameter and return types. Well, it didn't even put in the parameter types. Those are inferred. We know that they're strings, and I could put this in here, but since they're known, they have to be strings since that's what this array contains. It's not needed. Well, neither is the bool, because that's what sort takes. Sort takes something that returns a bool. It takes a closure that returns a bool. So we can just do away with that, and we're still good. Same return type. There's also the implicit return of a single expression closure. That means if you only have a single expression, you don't need the return. It's just going to return whatever this evaluates to. If I run it once again, same result. And then there's the shorthand argument names. This is, you can just use the shorthand argument names in place of the parameters. So I'm going to delete this. Now, what are V1 and V2? They're nothing. We haven't named them anything. But I could say $0 and $1, the shorthand argument names. It's a zero-based counting of all the parameters. So now I'm just comparing the two. Well, that's fine for sort, but what about for each? Well, same thing. For each, I can just say print $0, and it'll do that. And so on. Let total chars equal names reduce. Initial result 0. Ongoing and string, well, I don't need those. I know that the first one is the ongoing, the second one's the string, so I'll just say $0 plus $1.count, and it's going to reduce it. If I print it out, it'll have the total characters, 23. And to me, this is very readable. It takes a while to get used to it, but once you know what the parameters are, this is very readable, and it's very difficult to change the intention here. Somebody can't come in and start writing code because it has to be a single expression. Otherwise, it needs the return. So if this starts getting messed up, it's pretty obvious that that was not the intent. So hopefully, through these optimizations, you'll have more readable code. The first time I saw it, it blew my mind. But over time, I've come to love it. So another great optimization or powerful use of higher order functions is chaining. Higher order functions return something, right? Most of them do. Obviously, sort doesn't, but many of them do. And they often return things like collections, things that you were calling them on to begin with. So you could chain functions together and call other higher order functions on what was returned. So let's look at doing that. So once again, I'm going to delete all my code other than my array of names. And I want to look for the first name that has the letter E when they've been sorted. So I'm going to need two higher order functions for that. So I'll say let first E equal names dot sort. I'm going to call sorted because I want them returned. And then I'm going to say first where V1, I'll say, and I'll return V1 contains E. And again, I'll call lowercase on V1. Now we know from our optimizations we can do better than this, but let's go with this for now. Let's see if this works. So I'll print first E, and it should sort them, and it should come back with Andrew. There it is. Okay, but let's optimize this a little bit. So I'll comment this out so we can have the original version. And I'll say let first E equal names. And then you might want to go to the next line so you can kind of space them out and see each thing that's being called. And I want to call first, and I'm going to do it as trailing closer, but I'm going to use my optimizations. And I'm going to say 0 contains, and it knows what it is. It's a string, and E. And of course, I once again want to call lowercase on it. So now it should have the same result. It does. Now, which do you think is more readable? At first, you might say this one is, but over time, this looks kind of cluttered together, and what's going on here? I'm passing this in, and it's used down here. Contains E. What contains E? Okay, well, that's a name. Oh, that's right. It's sorted. This one's very clear. Names, sorted. I get the first one that the lowercase contains E. I don't know about you, but once I got used to this, it became very readable, very focused, very concise. And I only have to glance at certain things and I know exactly what's going on. And I think as you get more and more comfortable with these, you'll come to love them too. We want to talk real quickly on calling higher order functions on other types of collections. We've been focusing on arrays, but let's talk about sets. Let's make our name a type of set that contains strings. So if we wanted to call one of these functions on this, what are we going to get back? So let's look. We'll say names.sorted, and what does it come back? Well, that's an array. That's right. I mean, what does sorted mean? It means ordered. Well, sets by definition are unordered. So when you sort a set, it's actually going to turn back an array. So you have to be real careful about what you're doing when you call these higher order functions on other types. Obviously, reduce is still going to be the same thing, but maybe not in the same order. Let's try it. So our initial result is going to be an empty string. We'll have our ongoing, and then our string, which is going to be val, and then our result is a string. And we'll just return the ongoing plus val. Now, how can we make that shorter? What do you think? Maybe $0 plus $1. And then we want to store that. I'll call it let r equal names.reduce and print r. And then let's see what it prints out. All of them put together, but not in the same order. ASD, Bear, Jenna, Andrew, Kyle, because it's a set. So you have to be aware of what you're doing these operations on. You can still do them, but just be aware that sets are unordered and your results may be a little unexpected. So now we're going to talk about calling higher order functions on dictionaries. So we talked about it on arrays, we talked about it on sets. Now we're going to talk about it on dictionaries. So the parameter that's passed into your closures from a dictionary higher order function is a tuple. We've talked a little bit about tuples. On a dictionary, it's simply two values, a key and a value. The things that are returned vary, as we've seen before. Filter returns a dictionary with the items filtered out of it. Sort returns an array. So you have to look at the return types. Let's look at a couple examples. So back in Xcode, I'm going to delete everything. Goodbye to our beloved names array. And I'm going to create a new names. Let names equal, but this is going to be a dictionary. So we have LSU, and the name is Tigers. We have UNT, Eagles. These are the mascots. And then we have UTEP, which is the minors, as in digging in the ground, not under a certain age. So now we're going to filter the names. So let one val, or v1, equal names dot filter. Now notice the type that it takes in is a tuple. And we can decompose it here to the key value. It still returns a bool, so which ones do we want to keep? Return if the value contains a t. And maybe we should lowercase it and make the t lowercase, of course. So which one contains a value that has a t? It's the Tigers. So if we print v1, we should see LSU Tigers, and we do. Again, how can we make this a little more efficient? We could say .0, and of course it knows it's a tuple, so we look for the value, and there it is. It should be the same thing. Isn't that great? Doesn't that look great? So if we wanted to do a call on sorted, what do you think we'll get? We'll say let sorted equal names dot sorted, and again it takes a key value pair, so we're going to call sorted on it. So look at the type. It takes two tuples. So we have to construct that. So we'll have this first tuple be tup1 and the second tuple tup2. And then we're going to compare the values. Return tup1 dot value less than tup2 dot value. And then we print sorted. And what do we get? The sorted by values. And they're tuples. And it's an array of tuples. So we can make this more concise by using the $0 value and the $1 value. And of course, the output will be the same. So calling higher order functions on different types will result in different values. It still works just as great, and it's still awesome. The last one we're going to talk about, I know, it's sad. I didn't want it to end. I've enjoyed this, but the last one we're going to talk about is calling higher order functions on strings. So once again, I'm going to delete all the code in my playground, goodbye names, and I'm going to create a new value, and I'm going to call it just name, just one. And it's going to be a very long name, something like Jennifer Castim O'Brien, something like that. Okay, well, since strings in Swift are collections, you can call higher order functions on them, no problem. So we can say let total chars equal name dot reduce. And again, what's our initial value when we're going to add up the characters? 0. So the next result is going to be ongoing, and it's also an int. The next one is our char, and the result is an int. Well, this isn't very interesting because I'm just always going to return 1, but I have to add it to ongoing, and it's 18. That's not very interesting. We could get that by just doing name.count. We could upper and lowercase every other item, but we'd have to get the offset. So we'd say name.enumerated, and now we're no longer dealing with ints. So we're going to start with an empty string. Our ongoing will be a string, and the next value is still going to be a char, but we're going to return a string. So now, instead of adding 1, we're going to add the next character. So let's just add char for now and make sure that we get the new name. We just want to make sure that we're dealing with the characters. So it should be the same thing. Okay, well, that's a problem already. We're trying to add a tuple. So this is enumerated, so it is a tuple. So let's add the tup dot element, which is a character. Let's see if we can add those two. We can't. Why? Because they're different types. You can't add different types in Swift. So let's convert this into a string. Easy enough. And now we have the same name, but we want to upper or lowercase it depending on the position. So let's take this out and assign it. Let new string equal this, and we're going to add it and uppercase it if it's an even position. So we'll say tup.offset modulus 2 equals 0, then new string dot uppercase, otherwise new string dot lowercase. And now we should upper and lowercase every other letter. And that's what it does. So we can call higher order functions on strings or their enumeration from enumerated. We can do lots and lots of things with higher order functions. We can chain them together. Whenever you are processing collections especially, chances are you could probably use one of these. It makes it very concise. It helps make it very efficient, and it also makes it very communicative to other developers. So I strongly recommend you use higher order functions when you possibly can. It also makes you look really cool. It makes you look like you know exactly what you're doing, and you know what? I think you do.